Okay, hello, hi. This is Rani Ahmed with you, and this is lesson 26 in how to program using Haskell programming language. And in this lesson, I'm going to talk about classes and types. Now, this lesson is not the classes that we know in Java or C++. It's not OOP. It's not object-oriented programming. That's OOP. So here, the main difference, as we have just written here, okay, that classes are not types but categories of types. Usually in Java you use the keyword new just to create a new variable. Here you don't create a new variable when you have defined a class, okay, and the class is a type. No, a class here is a category of type, okay. So that's the main difference between classes in Haskell and classes in other programming languages like Java and C++ and Objective-C and so on. Okay. Now let's start with a definition of a class and how it's done. Okay. Now this is the class EQ. Now we know EQ is something from preload, and just as a reminder, preload is the preloaded libraries once you get into Haskell. Okay, those are the things that you really need just write on, okay, and they're already included, so it's pre-included to you, and those are standard in Haskell. So EQ is one of them. So the code here is just a way to tell you how EQ is defined. Okay, so I know you're reading, but it's important that I explain things to you. Like we say class EQ of A, where I have those functions, which is the equality and the not equality, okay, are functions belonging to the class EQ. Okay, and EQ, if I want to talk about the equality or the not equality, yes, both take two numbers, because you want to say, for example, x not equal to y or x is equal to y, okay, and both should give you a boolean value, whether it's a true or false, because this is what a boolean should be, a true or false. Now this is a minimal definition of the functions equality and not equality. So you say that x not y is not x equals to y, okay, and similarly on the other side, okay, x equals y is not x not equal y, okay. So because of those two things, you're getting some kind of recursion, okay, and therefore you're getting the correct definition of both functions, okay. So this is how I define a class, okay, in Haskell. Now there is another thing called the deriving keyword, okay, and deriving means that, for example, I don't have to redefine what's the equality, what's the comparison using OR, what's the way to show things, okay. So Haskell gives us a way to get them right on without me redefining everything, okay. So this is where derivation comes in. So I'm saying, like, I have a foo data type, some data type, okay, which is defined by some constructor foo, okay, and it takes a data, takes two values, an integer x and some string str, okay. This is str. So and I wanted to use the equality just to make it like another value to be compared with another value of the same type foo, okay. So I use the equality also with the OR just to do comparison, and show just to print things out on the screen. Now this is where those things that you should usually derive from Haskell prelude, okay. Equality, you know, those are functions for equality, equal and not equal. We've got ordinal for comparison operators, okay, you know, less than, greater than, less than or equal, greater than or equal. And we've got other functions, those are just string named functions, not symbols like here. Minimum for the minimum, to get the minimum between two values. Okay, maximum, the maximum of two values, and we've got also the function called compare to compare, and gives you less than, greater than, and equal. So, and compare, we've seen it somewhere with a case statement, I think. Okay, as far as I remember. Now I've got here the enum for enumerations. Okay, and it allows the usage of blue, green, things like that when we had the enumerations. Okay, so this means if you used enum inside the deriving, you can use the list as such. Okay, as an enumeration. Now we've got also the bounded, which means that you've got two bounds, the minimum bound and the maximum bound. Okay, and this gives you two functions, one for one the minimum bound, and one is called the maximum bound. Okay, and as you see, okay, it can be used on types that have only one constructor. Now also we have the show, which means that I'm using it to print things on the screen, for example using the function called print string line. Okay, and we have got also the read function to read from the screen. Okay, and other functions, of course, okay, that are inside this type and this type. Okay, now here we talk about also something called class inheritance. Now class inheritance is that when I say EQ, okay, gives ORD, which means ORD has not to go outside from the EQ. It has to be part of the EQ. Okay, so EQ gives itself to ORD. Okay, which means it gives all the functions that it has inside this class EQ to ORD. Okay, and we see ORD, it's the comparison class. Okay, so this is the definition of ORD if you want to see. Compare is, for example, I take two numbers or two values, and it should give me that type called ordering. Okay, and also those are the functions for comparison. All of them, okay, are defined as they take two values, okay, and it gives me a Boolean value as a result of those functions. Or we have also the min and the max. Okay, it takes two values and gives me finally a single value. Okay, of course it should be the minimum value or the maximum value. Okay, now here is another way to have inheritance, which means that unlike in Java, for example, you talk about one or like just single inheritance, not multiple inheritance. Okay, which in Java you can just take from one class. Okay, in C++ you can do multiple inheritance, which means like I have so many classes and I can take their functions too. Okay, but here also in Haskell we have multiple inheritance, which means that if I'm talking about a real number, it has to use the class of ORD and it has to use the class of number of A. Okay, and please don't mix the classes of Haskell with the classes that you see in OOP. Okay, and we just shed a spot on this. Okay, shed a light on this. So and there is a function here inside the real, which is here as it says the rational equivalent of its real argument with full precision. So if I take a real number, okay, it should give me rational. Okay, like a number of type rational. Now prelude here in the book, okay, has its own hierarchy of inheritance. Okay, so this is in bold, those are the names of like EQ and show and read. Those are the class names. Okay, and for example, if I'm talking about ORD takes from EQ. This is the meaning of the arrow, the black arrow here, and we've got here also the number, which takes from show and EQ. You know, you need to print the number and check the equality. And here it says, for example, I all except the IO, which means the printing and printing and taking input. Okay. And this is just to talk about the function named the arrow sign. Okay. So those are inside EQ, but those two things, IO and the function arrow sign. Okay. And here's the rest of the class definitions. And we've got here also talks about the list. Okay, when you see those brackets. So monad, for example, uses the list. Okay, now also if I want to talk about constraints, which are the limits in the type, if I want to put some limits on some type, if I say, for example, num A, show A, B, show B, okay, are the A, like 3 parameters here to give me a string. 3 parameters on a function to give me a string. So you're saying the first parameter must be a number A, okay, second parameter has to be of type show A, which means something that I can print, and the third parameter has to be something that I can print too. Okay. So to give you, of course, finally something in the end. Okay, so this is how you just like making the string, making the input, okay, constrained to some types. Okay, so you're forcing the string to be of some type. Anyway, so you got the point. So that's all about this lesson. Please click the likes, click the comments, type your comments, type subscription, everything that you can. Please do it just for us to keep moving with this series. Thanks for watching.